Okay. So we'll start the second session. So far you have studied the bar fixed at both the ends. That is what there comes under statically determinate case. When fixed at one end, one horizontal reaction, one vertical reaction, one moment reaction, they can be determined by using sigma h is 0, sigma v 0, sigma m is 0. So they are called as statically determinate bars. Whatever you have studied as what a statically determinate, what is the meaning of statically determinate? Reactions can be determined with the help of the static equilibrium equations. That is by using sigma h0, sigma v equal to 0, sigma m equal to 0. Now you are going to study the statically indeterminate bars. Statically indeterminate bars. Statically indeterminate means the reactions cannot be determined. Reactions cannot be determined with the help of the static equilibrium equations. Means number of reactions are more than number of static equilibrium equations. If the reactions are 4, equations are only 3, then it comes under statically indeterminate. Statically indeterminate means the reactions cannot be determined with the help of the static equilibrium equation. When a bar is fixed at both the ends, when a bar is fixed at both the ends, reactions, two horizontal reactions are there now. Equation is only one, sigma h is equal to 0. By using the one equation, two unknowns cannot be determined. Then it comes under statically indeterminate. To determine the two unknowns, we need the two equation. One equation is that sigma h is equal to 0. And what the another equation now? Net change in length of the bar should be 0. When it fixed at both the ends, what now? Change in length of the bar is 0. Then you have to use a one more equation called as what now? Compatibility equation. That equation written in terms of the deformation. So when I fixed at both the ends, the reactions are determined with the help of sigma h is 0 as well as what now? Net change in length of the bar equal to 0. So once you know the reaction, the problem is same as the previous question only. Statically indeterminate bars. Bar fixed at both the ends, or you can also call the hinged at both the ends. How many supports are going to be there now? Fixed support, hinge support and roller support. Fixed support, 3 reactions are going to be there now. Horizontal, vertical and moment reaction. Hinge support, 2 reactions are there. Sorry, hinge support, you are getting 1 reaction. How to decide the number of reaction? Number of reactions are equal to number of restricted motions. Number of restricted motions. Fixed support will not permit any motion. it will restrict the axial motion, vertical motion, rotation. Since the three motions are restricted, axial motion, vertical motion and rotation. So number of reactions are 3. Hinge support, number of reactions are 2. Number of reactions are 2 means it will restrict the two motions, that is axial motion and vertical motion. Number of reaction in hinge support equal to vertical and horizontal reaction. And if you go for a roller support will restrict only one motion, that is the vertical motion. So number of reaction at roller support is going to be only 1. Number of reaction at roller support is 1. Number of reaction hinge support is 2. Number of reaction fixed support is going to be 3. So which support will permit the change in length or axial motion? Only roller support will permit the change in length. But fixed support as well as hinge support, fixed support and the hinge support will restrict the axial motion. So whenever for me what a change in length of the bar should be 0, even after the application of the load, even after applying the axial load will cause a change in length. But for me change in length should be 0. After applying the axial load also, for me change in length of the bar should be 0. Then in that case, either I can use the 2 hinge supports or 2 fixed supports or 1 fixed and hinged. 1 fixed and hinged. Generally most of the textbook they are calling as what now? Fixed support. But you can also use the 2 hinge supports. That's why I written as what now? Bars hinged at both the ends. Or what the other combination I can use it now? Fixed and hinged. So whenever change in length of the bar should be 0 in presence of the axial load, either I can use the 2 fixed supports or 2 hinge supports or 1 fixed and hinged. 1 fixed and hinged. Only fixed and hinge support will restrict the axial motion. But roller support will permit the axial motion. Number of reaction at roller support is only 1. It is restrict only vertical motion. Hinge support will restrict the vertical motion as well as axial motion. Hinge support will restrict the vertical motion and axial motion. So number of reaction 1 vertical and 1 horizontal reaction. Fixed support will restrict the axial motion, vertical motion, rotation. Then you are getting rotation is restricted, moment reaction will be there. So fixed support 3 reactions are there. So moment reaction is possible only at the fixed support. Moment reaction is possible only at the fixed support. If the moment reaction should be non-zero, rotation to be restricted. The rotation is restricted. Rotation is restricted. Only fixed support. But what about the roller and hinge? Roller and hinge support. Roller and hinge support will permit the rotation. So the roller and hinge support, moment reaction is 0. Roller and hinge supports are called as a simple support. What is the meaning of simple support? They will permit the rotation. What the other name for fixed support now? Built-in support. Built-in support. Roller support and hinge support. What the other name for hinge support? No, pin support. How many motions are possible in a plane? In a plane, there are three motions are possible: axial motion, vertical motion, and rotation. In a plane, there are three motions are possible. If we consider this duster na, is a plane, board is a plane na. So how many motions will get it now? This is what axial motion, vertical motion, and this will be a rotation will be there. So always in a plane there are three motions are possible: vertical, axial, and rotation. If all these three motions are restricted, is a fixed support. If only rotation is permitted, it is a hinge support. When axial motion permitted means a roller support. Number of reaction is 1. How to decide the number of reaction? Restricted motion. It will restrict only one motion. Here number of reactions are 2. So 2 motions are restricted. 2 motions are restricted. There is the vertical and axial. Here this will restrict only vertical motion. And this will number of reactions are 3. So all the motions are restricted. So number of reactions at any support is equal to number of reaction at any support equal to number of restricted motion by that support. Now how to decide now which support I have to use it now? Whenever rotation to be restricted, these two supports are what? A rotation is permitted always. What the basic difference between these two now? These support will permit the rotation, but this will be restrict the rotation. So whenever a rotation to be restricted, only one option. Which option now? Fixed support. So the compulsory when rotation to be restricted. Rotation to be restricted. And whenever you need whenever you need a rotation, these supports are compulsory when rotation is to be permitted. Compulsory when rotation has to be permitted. If you take a door attached to door frame, a door is attached to door frame. What the motion required for a door now? Rotation is required. Then automatically simple supports are going to be required now. Now, but how many simple supports are there now? 2. Now when should I go for a hinge support and when should I go for a roller support? I need only rotation is required. I need only rotation. Only rotation to be permitted. Only rotation to be permitted. This I have to take it now. Only rotation to be permitted. This compulsory when rotation to be restricted. When rotation to be restricted, this is compulsory. When rotation to be permitted, how many options are there? No, 2. Roller and hinge. Then how to decide the roller or hinge? I need only rotation required. Door attached door frame, you need only rotation required. Then you can go for only hinge support now. When only rotation has to be permitted. Only rotation is to be permitted. That is both vertical and axial motion to be restricted. Only rotation is to be permitted. So overall what now? Which support is what restricting the rotation? This one now. And which supports are restricting the axial motion too? Is also all the motions are restricted here now. Here all the motions are restricted. So which support will restrict the axial motion? These two will restrict the axial motion. But I need only axial motion. Then you have to go for a roller support. When axial motion is to be permitted, this compulsory when axial motion is to be permitted. Once again I am discussing what now? Horizontal member. General beams are horizontal. So all my conclusions are valid about a horizontal member. This will restrict all the motion. This will restrict two motion. This will restrict only one motion. Here only vertical motion restricted. Here vertical and axial is restricted. Here vertical axial rotation. But how to decide it means what? This is a compulsory when rotation is to be restricted. Because these two will permit the rotation. So whenever I rotation, this is only one option. Next, which support will permit the rotation? These two simple support will permit the rotation. Since rotation is permitted, here always moment reaction 0. So always at the roller and hinge support, which reaction 0? Moment reaction 0. But here moment reaction is non-zero now. Why moment reaction non-zero? Because rotation is going to be restricted. So always at roller and hinge support, simple support, moment reaction is 0. Because rotation is permitted. Moment reaction develop when only rotation is restricted. Now, but two options are there, roller and hinge. Then which one I have to do it now? Shall I go for a roller or both will permit the rotation? Now which one I have to take it now? I need only rotation. I need only rotation. Means axial and vertical motion should be restricted. That only I written now. Compulsory when only rotation is permitted. Means axial and vertical motion is restricted. Therefore reactions are 2. And when this is a compulsory, this will permit the axial as well as what? The rotation. Already rotation is permitted. But this compulsory when axial motion is permitted. Because this is restricting the axial motion, this is also restricting the axial motion. So when axial motion restricted, so whenever axial motion is permitted, whenever axial motion permitted is a roller support. Whenever axial motion is permitted is a roller support. If only rotation is permitted is a hinge support. When rotation restricted means a fixed support. How to identify in the question which type of support now? If a support is permitting axial motion means obviously the roller support. If a support is what? A permitting only rotation is a hinge support. If a support is restricting the rotation means a fixed support. Is a representation of roller support. But the other way can also represent it now. Roller support can also be represented by like this. This is a representation of roller support. What the meaning of this zigzag line? Means I have shown the part of the member on which side? On the left side I have shown. Means right side portion is there. I have shown only on the extreme left side I have shown that. What now? I have shown the left side portion I have shown it now. Right side we don't know. I have shown the what? A part of a beam on which side? On the left side. Or a part of a member on left side. So the roller support is a roller support. Both the ways you can represent it now. So here how many motions are possible? Axial motion is possible. Rotation is possible. So since axial motion permitted means horizontal reaction 0. Rotation is permitted means moment reaction 0. Only which motion restricted now? Vertical. So your reaction will be one reaction. Since only one reaction, directly can write down Ra. So number of reaction at roller support is what? 1. But how this reaction is acting in roller support? How this reaction is acting at roller support now? What this blue color line? What this blue color line? What this black color line is called now? Plane supporting the rollers. Plane supporting the rollers. Sorry, this, okay. Plane supporting the rollers. Now what the reaction between this what the relation between this reaction and this black color line? This black color line is about a plane supporting the rollers. So what the relation between this reaction? Both are perpendicular. Means roller support reaction is perpendicular to plane supporting the rollers. Plane supporting rollers. Now, at A, how many loads are possible now? A is about, this line is a horizontal line. This black color line is longitudinal of the beam, longitudinal of the member. What this A now? Extreme left side. Here, how many loads are possible? At every cross section, how many loads you have studied now? Every cross section, how many loads you have studied now? Axial load, shear force, bendment and twistment. Now here, how many loads are possible? Only vertical reaction. Which load is 0? Axial load 0, bendment is 0, twistment is 0. Only which will be there now? Only shear force is there. Only vertical reaction. Means what the conclusion now? When a roller support is provided at the extreme end, which extreme end? Left side. When a roller support is provided at the extreme end, at that cross section, then you are getting only, at roller support you are getting only shear force. Remaining all the loads are 0. So in this case, at A, axial load, bendiment, so when the roller support is provided at the extreme end of the member, when roller support is provided at the extreme end of the member, at that roller support you are getting only shear force. Remaining loads are 0. To get an axial load, what is required? Horizontal reaction. But horizontal reaction 0 because permitting the rotation. Why bendment is 0? Moment reaction 0. Moment reaction is 0. When what this figure represents, the roller support is provided at the extreme end. Which extreme end now? Extreme left side. So when roller support is provided at the extreme end of the member, then you are getting only shear force is possible now. and here only one reaction, but that reaction become as a vertical reaction. But here, what the reaction is, vertical reaction or horizontal reaction? It is the inclined. One reaction only will be there now. But how the reaction will be there now? In roller support, how the reaction is there now? This angle is what, a 90 degrees. Now the vertical reaction or horizontal or inclined? It is inclined. For the beam, it is inclined. But in the previous case, here also here you are getting one reaction only. But this reaction for the beam will become as a vertical reaction. But here for the beam, this reaction will become as a what now? Vertical or horizontal or what? Inclined. Inclined. Then if you resolve it, how many components are going to be there? One horizontal and one vertical component will be there now. Same conclusion now. Reaction is perpendicular to plane supporting the rollers. Here also perpendicular. So if somebody will ask now, at roller support, how many reaction means one? But is it a horizontal or vertical or inclined? Depend upon the plane supporting the rollers. Now what this black color line? Plane supporting. So this plane now parallel to axis of the beam. So when the plane supporting the roller is parallel to axis of the beam, it is a vertical reaction. But here, this plane is what now? Inclined to the beam. This plane is what now? What this line now? Plane supporting the roller is inclined to the beam. Generally, you are going to come across this only. But some of your engine mechanics, some of the paper they are giving now. So in this case, the plane supporting the roller is inclined to the beam. Once again, reaction is one. But with respect to beam, how many reactions will be there now? Two components is there now. One vertical and one horizontal reaction will be there now. Now, in this case, how many motions are restricted now? Vertical motion restricted, axial motion restricted. So when you have to use this type of roller support, when both vertical and axial motion restricted, but default in the question, if nothing is mentioned, we are going to consider roller support like this only. Why? Beams are always loaded with a TSL. So to restrict that, what the beams are loaded with a what? A TSL or axial load. Beams are loaded with a TSL. So to restrict the vertical motion, generally default this is used now. Default this is used. In one of the GATE civil engineering paper, the question was given like this. In this case, now the reaction will become the horizontal reaction. Horizontal reaction. But what is reaction zero? There is no use of the support here now. Now vertical motion is permitted or restricted? Now permitted. No downward load. No reaction is upward. The vertical motion is permitted. So here what this reaction value? Now 0. If there is no axial load, this reaction is 0. So there is no use of this support now. There is no use of this support. Here vertical motion permitted or restricted? Now vertical motion is going to be permitted. So this can be considered about a cantilever beam subjected to point load now. So this can be taken as about a cantilever beam subjected to point load downward now. So what is the conclusion now? Roller support number of reactions is 1 only. Is it a horizontal or vertical or what the answer now? Sir, it may become as either horizontal or vertical or inclined now. How it is possible means what now? Sir, always in roller support the reaction is perpendicular plane supporting the rollers. Hence, either they become as a horizontal or vertical or inclined. Depend upon the plane supporting the. Here, how this plane supporting the roller na parallel to axis of the beam. How here plane na perpendicular to axis of the beam. And here inclined to the axis of the beam. This is what now? This is the plane supporting the rollers. So here plane supporting the roller is perpendicular axis of the beam. When plane supporting the roller perpendicular axis of the beam, it will become the horizontal reaction. When plane supporting the roller parallel to axis of the beam is a vertical reaction. When plane supporting the rollers is what? Is inclined to the beam, then it is going to be a what now? The reaction will become the inclined. Then you are going to get one horizontal and one vertical. But if nothing is mentioned, default, you are going to mention the roller support means this one you are going to take. It means if nothing is mentioned, we are considering the roller support in such a way that the plane supporting the roller is parallel to axis of the beam. That's why everybody is going to mention the roller support is going to be one vertical reaction will be there. So if somebody will ask roller support means number of reaction is 1. Is it a horizontal or vertical mean what the answer now? Sir, in roller support the reaction is perpendicular to the plane supporting the rollers. Hence it may become as vertical or horizontal or inclined. Depend upon the plane supporting the rollers. But when plane supporting the rollers is parallel to axis of the beam is a vertical reaction. If nothing is mentioned, this you are going to consider. Why now? Because beams are loaded with a TSL. So what is the purpose of this now? Here there is no use of this now. There is no use of this support. This motion is permitted here now. What is the purpose of this support now? To restrict the motion. If I am going to provide the beams are loaded by constant at point load, TSL. But here there is no use of this support now. But here beams are loaded by constant. Now it will restrict the vertical motion. It will restrict the vertical motion. So why you are taking this one means what? Always the beams are loaded with a VTSL, vertical transfer shear load. That's why default this will be considered now. This is what now? What this black color line? Longit axis of the beam. This is a support. What this red color dot? Pin. These two are both are connected by means of a pin. So this beam is what now? In the previous case, the beam is simply kept on a support. There is no connection between these two now. This beam is simply kept on this support. There is no connection now. But here, this beam is joined to this support. This beam is joined to this support with the help of a pin. That is what this marker now. So where you can see this marker now? In the side view. In the front view, it will become as a dot. So this is called a hinge or a pin. Hinge or a pin. Now because this one what happens now, if I apply a load now, so this pin will restrict the what now? Axial motion. Now this will permit only rotation. Only rotation is permitted. Now which motion restricted? Vertical and axial. One vertical reaction. Horizontal reaction. What the other way you can show it now? Your theory of machine, mechanisms, problems now. Mechanisms. You are going to study the hinge joint. This is another way you can represent. This beam is joined to this support with the help of a pin. This dot is nothing but a pin. That pin can be seen in the either side view or top view, but front view become as a dot. RAV, RAH. Once again, moment reaction 0 because rotation is permitted. Now this is once again what now? I have shown on the left side. So this hinge support is provided the extreme left side. Extreme left side. I have shown the left side portion. So remaining portion will be on the right side. Remaining portion will be on the right side. So here how many loads are possible now? Axial load is going to be minus RAH. Shear force is RAV. And bend moment is 0. But when roller support is provide the extreme end, what you got it now? Only shear force. But here you are getting shear force and axial load. When a hinge support is provided the extreme end. Extreme end. This is called the provided the extreme end. We are going to get one axial load and one shear force. Bend moment and twist moment is 0 because moment reaction is 0. This is a representation about the fixed support. This is a beam, this is a wall. This line is about the beam, longitude axis of the beam. This is what now? Wall. The beam is built inside the wall. Beam is built inside the wall. That's why it is called about a built-in support. Built-in support. Built-in support. Now here all the motions are, since it is what a built inside, rotation not permitted, axial motion not permitted, vertical motion not permitted. All the motions are restricted. Once again, what the meaning of this zigzag line now? We are showing the portion of the beam on the left side. Means some portion on the right side will be there now. We don't know which support on the right side now. We are showing on the left side now. So this is what a fixed support or a built-in support. So here horizontal reaction will exist, vertical reaction will exist, and moment reaction will exist. But in the previous two cases, moment reaction 0. Because of rotation they are permitted, but here rotation is restricted. So here at A, minus RAH, what the shear force now? RAV, and bendment is now question will be at roller support and hinge support, bendment is 0 or non-zero. At roller and hinge support, bendment is 0 or non-zero. At roller and hinge support, bendment is 0 or moment reaction 0, or both are 0. At roller and hinge supports, bendment is 0 or moment reaction is 0, or both bendment and moment reaction are 0. Which of the following statements are correct now for with respect to simple supports? At roller support and hinge support. At roller and hinge support, bendment is what now? 0 or non-zero. Question like this now. Which of the following statements are true? At roller and hinge supports, moment reactions are 0. Bendment is 0. Third one what now? Both shear force and bendment are 0. Both moment reactions as well as what? Bendment is 0. Last one, moment reaction is 0, but bendment is non-zero, or may not be 0. Fourth statement like this now. At simple support, that the roller and hinge supports, which of the following statement are true? First statement is at simple supports, moment reaction is 0. Second statement, bendment is 0. Third statement, at simple support, both shear force and moment reaction and moment reaction is non-zero, bendment is 0. Moment reaction is non-zero and bendment is 0. Last one, moment reaction is 0, but bendment may or may not be 0. In that case, what the answer now? A and D are correct. So always at simple support, moment reaction is 0. But bend moment may or may not be 0. Hence answers are what now? A and D. A and D. But everybody is going to take the bend moment 0. Sir, you have mentioned bend moment 0. But this provided the extreme end. So always remember what now? At simple support, moment reactions are 0. But bend moment may or may not be 0. Bend moment may or may not be 0. But here why the bend moment is 0 now? It is provided the extreme end. Provide the extreme end. If a question is mentioned what now? When simple supports are provided the extreme end. When simple supports are provided the extreme end. In that case, both moment reaction and bend moment both are going to be 0. Both moment reaction and bend moment are 0. Extreme end. What is the other name for this now? A roller support at the extreme end. In this case, it's the hinge support and a roller support. Here which one is 0? Now bend moment is 0. But here bend moment is not 0. But at both the support, which one is 0? Now moment reaction 0. But the bend moment now W into BC. Suppose this distance is L by 4. L. This is not provide the extreme end, but this is provided the extreme end. So when a simple support provided the extreme end, both moment reaction and bend moment are 0. But here, moment reaction 0 because permitting rotation. But what about the bend moment? Algebraic sum of the moments, WL by 4. So here, moment reactions are 0. But here, bend moment is 0. But here, bend moment is 0. This is at the extreme end, this is not at extreme end. This is called as a simply supported end. Simply supported end. What is the meaning of simply supported end now? Simple support provides the extreme end, but this is called a simple support. It is a simple support, but this is called as a simply supported end. In this case, what now? What the bend moment now? 0. What the bend moment now? Algebraic sum of the couples and moment. What the moment now? W into L by 4 negative. This is a positive. Here bend moment is 0. That's why what I mentioned now. At simple support, bend moment may or may not be 0. But moment reactions are 0. In the previous case here bend moment is non-zero. But here bend moment is 0. Because of what the right side one couple is there, one moment is there. Here so once I am mentioning now, at simple supports always moment reaction is 0, but bendment may or may not be 0. Here it is non-zero, here is 0. But at simply supported, these are the what a simply supported end. At simply supported end, both moment reaction and bendment are 0. At simply supported end, when simple supports are provided the extreme end, both moment reaction and bendment are 0. But simply simple support means what now? Moment reactions are 0 because they are permitting the rotation. Bendment may or may not be 0. What the bendment definition you have studied now? Bendment is the algebraic sum of the couples and moments. Bendment is about the algebraic sum of the couples and moments are both are going to be there now. But where both are 0, at simply supported end, at simply supported ends, both moment reaction and bendment are 0. At simply supported end, both moment reaction and bendment are 0. That's why what that question I mentioned now. At simple supports, which of the statements are correct? Means first statement is moment reactions are 0. Bendment is 0. Third one is what now? Moment reactions are 0. Bendment is 0. And last one is what now? Moment reactions are 0. Bendment may or may not be 0. What the answer now? First statement is correct. Moment reaction 0. Last statement is also correct. Moment reaction 0, but bendment may or may not be 0. But if you ask the same question, what are same statements, at simply supported ends, which of the moment reactions are 0, bendment is 0, both moment reaction and bendment is 0, moment reaction 0, bendment may or may not be. At that time, A, B, C, moment reactions are 0, bendment is 0, both are 0. So in that case, A, B, C are correct now. But most of students, their simple what? The textbooks are mentioning what now? Low standard textbook. Simple support bendment is 0. Simple support bendment may or may not be 0. But moment reactions are 0. The statement is correct at simply supported end. Simply supported end. This is called as simply supported end. It is also simple support. It is also simply supported. Both are simple supports only. But this provides the extreme end. But this is not provide the extreme end. Why moment reactions are always 0? Because they are permitting the rotation. But bendment depend upon what? Algebraic sum of the couples and moments, either left side or right side now. One friend is given, both are 0. One friend is given, only moment is 0. There are 4 statements. Out of the 4 statements, A and D are correct for simple supports. A, B, C are correct for simply supported ends. Simply supported and what? Now both bendment and moment reactions are 0. Now this duster is provided by what? Supported by hand. This duster is supported by my hand. This hand is what? Supporting the duster. So this hand is considered which support now? This hand. This duster is supported by my hand. My hand is nothing but a support now. Now shall I consider this a roller or hinge or a fixed support? Supports are 3: roller, hinge and fixed support. So which support it is now? Somebody is going to tell, sir, fixed support. Somebody is going to tell hinge support. Somebody is going to mention roller support. Which support it is now? How to decide the support now? Which motions are permitted? This will permit vertical motion is restricted. Only vertical motion restricted. Now you can see now this is the axial load. Axial motion is permitted. Once the axial motion permitted means a roller support. So my hand is treated as a roller support. My hand is taken as about a roller support. But if it is going to fixed support. How you decide there is a roller support? If I apply an axial load here now, this marker will axial load. It will push this duster now. My hand is permitting the axial motion of the duster. Once the axial motion permitted means the roller support. Even if I apply load like this now, it will permit the rotation is permitted. Rotation is permitted. Only which motion restricted now? Vertical motion. Now what this marker is doing now? Pushing the duster downward. Pushing the duster downward. But the duster is not moving downward means what now? My hand will offer a reaction. Which reaction? A vertical reaction. So my hand will offer a only vertical reaction. So my hand is permitting the how many motions now? Axial motion of the duster as well as the rotation. So this hand is taken as a roller support. So whenever an axial motion is permitted, axial motion permitted for horizontal member, directly are calling as a what now? Roller support. Now this duster is supported my previously what now? Duster is supported my hand. Now this duster is supported my two fingers. My two fingers. Now how this duster is joined to this my fingers now? How this duster is joined to my fingers now? We are going to make a hole. We are going to make a hole. A pin is going to be driven inside. So this duster is joined to my finger with the help of a pin. This duster is joined to my fingers with the help of a pin. Now if I am going to apply a load like this now, the marker is pushing the duster towards right side. But the duster is not moving towards right side means what now? Because the pin is there. That pin is restricting now. Pushing like this now. The duster is not moving towards right side. Axial motion restricted. Vertical motion restricted. But what about now? Rotation is permitted. Rotation is permitted. So my fingers are permitting only which motion? Rotation. When only rotation is permitted, but a hinge support. So this is called a hinge support. So my fingers are behave like a what now? Hinge support. But previous case, my hand is behave like a what? A roller support. Like this now. Both hands what now? Two hinge support. So only which motion is permitted now? Only they are permitting the only rotation is permitted. Only rotation is permitted. So this is nothing but what? A simply supported beam. Two hinge supports extreme end is simply supported. And last one is what now? This duster is kept inside my hand. It is kept inside my hand. Means built inside the support. Just like a wall in a buildings. The wall is, beam is built inside the wall. It is built inside my hand. Now if I am going to push it like this. If I push it like this. Axial motion is what? A duster is this moving the water towards left side. But duster is not moving towards left side. Even what now? If I apply load like this now, it will try to rotate the duster. But this end what now? rotation is restricted. This is what now? It will tries to rotate, but this end what? Here rotation is permitted, but this end what? Rotation is restricted. So this is what now? Fixed support. When rotation is restricted means what now? My hand is offering a moment reaction. This load is what now? Horizontal TSL. It is giving moment in which plane now? Horizontal plane clockwise. But it tries to rotate like this. Here this end is permitted, but this end is rotation restricted. But this is restricted. So my hand is offering a moment in which plane now? My hand is offering a moment in which plane now? Same plane but anti-clockwise direction. And vertical motion restricted. So this is called as what? A fixed support. Fixed support. Here nobody is going to make a mistake. Fixed support, they are going to tell it now. But previously this is only what everybody is going to tell. Sir, hinge support, fixed support, roller support. This is a roller support. So how to decide type of support now? How to decide the type of support? When axial motion is permitted, simply take it as about a roller support. When only rotation is permitted, is a hinge support. When rotation restricted, it is a fixed support. So this is now we are coming to this topic now. Now once again this supports tomorrow, day after tomorrow I am going to discuss the SFD, BMD. Once again they will not be discussed now. So calculation of what reactions are very important now. So here what you are studying, the bar means axial load. For me change in length should be 0. If the change in length should be 0, either add to the two fixed supports or two hinge supports. Two fixed supports or two hinge supports. Or what the other combination, roller and hinge also, sorry, fixed and hinge also can be used now. Whenever you want to restrict the change in length, either you can use the two hinge supports or two fixed supports or one fixed and hinge. One fixed and hinge can be used it now. A member is said to be statically determinate. Member is said to be statically determinate. When total number of non-zero reactions is equal to useful static equilibrium equations. Useful static equilibrium equations. When a bar in this example, is a statically determinate or indeterminate now? Determinate. How many number of reactions now? Non-zero reaction is only one. Non-zero reaction is only one. And how many equations are there? No, only one. Should not compare with the total equation. You have to compare with the useful equation. Total equations are 3. But here for this question I can use only sigma h is equal to 0. So you should not see the total number of reactions. You have to see the non-zero reactions. How many non-zero reactions are here now? 1. And how many equations are there now? Only 1. We can use only sigma h is equal to 0. There is no use of sigma v and sigma m. So this is going to be calculated by using sigma h equal to 0. Number of non-zero reactions. One. Total reactions are 3, but vertical and moment reactions are 0. So non-zero reaction is only 1. And number of useful static equilibrium equation. Static equilibrium equation only 1. That is one equation, one unknown. Therefore, it is a statically determinate bar. But I am now going to be fixed here now. Then you are going to get the two non-zero reaction. Equation is 1. Then it is statically indeterminate. A member is said to be statically indeterminate. Indeterminate. When total number of non-zero reactions are greater than at this word number of useful static equilibrium equations greater than useful static equilibrium equations. So this will come under what now? Statically determinate bar. Statically determinate bar. Hence, reactions are determined statically indeterminate. Reactions of a statically indeterminate member are determined with the help of useful static equilibrium equations and compatibility equations. Compatibility equation, and that compatibility equations are written in terms of deformations. When a bar fixed at both the ends, then you are going to write down the total change in length 0. So, this compatibility equations are written in terms of deformations. Deformations or deflection. In bars, your deformation beams deflection are written in terms of deformations. So number of compatibility equations equal to number of non-zero reactions minus number of useful static equilibrium equations. So generally what the one support is sufficient here now. Why you are in the another support now? Why you are in the another support? To support this load, one support is required. Fixed support is sufficient now. Why you are in the another support now? Now because of this load, what happens now? Change. If I remove this support now, if I remove this support, the bar is in equilibrium condition only. But change in length is going to be non-zero. If I remove this support, what happens now? It is the equilibrium, but change in length is non-zero. But for me, what the change in length should become zero. Change in length should become zero. Even after application of the load, the total length of the bar should remain same. Length should not change. Then in that case, either you have to go for one fixed support or two fixed support should be used or two hinge support should be used it now. Or what the other combination you can use it now? One fixed and one hinge can be used it now. One fixed and one hinged can be used it now. Generally most of the textbook they are giving this only. But one of the gate paper this question is given like this. And students are what now? Sir, you are not discussed the hinged at both the ends, sir. Same concept is going to be there now. So whenever you want to what now? Restrict the change in length of a member. Change in length of a member under axial load. Want to restrict the change in length of a member under axial load. Three options are there. Either you are to the two fixed supports or two hinge supports or one fixed and hinged. Both are what here what the total number of reaction. Here 3, here 3. Total is 6. Here what the total now? 2. One horizontal, one vertical. One horizontal and one vertical. Here total number of reactions are 4. Total number of reactions are 6. But you have to see the non-zero reaction. In both the case what now? Here which reaction 0? Vertical reaction 0. Whenever you want to get a vertical reaction, either there should be a constant point load or a constant moment is required now. So here both the case what now? Which reactions are non-zero now? Vertical reaction, out of the 6 reactions, total how many reactions are there non-zero now? Out of the 6 reactions, only 2 are non-zero, 4 are 0. 2 vertical reaction 0, 2 moment reaction will be 0. Here total reactions are 4, here 2, here 2. Out of the 4 reaction, 2 are 0. 2 vertical reaction 0, only horizontal reaction will be here now. But some students are going to be what? Sir, is statically determined, sir. 2 unknowns, 3 equations. Sir, equations are 3. Should not compare with the total equations. We can use only sigma h. When there is no vertical load, how can you use the sigma v equal to 0? When there is no moments, no couples, we cannot use the sigma m equal to 0. So non-zero reactions are 2. Equation is 1. Non-zero, both are going to be comes under statically indeterminate. Number of non-zero reactions. Number of useful static equilibrium equation. Only 1. Unknowns are 2, equation is 1. So it comes under statically indeterminate. Sigma h is 0. Sigma h is 0. So it comes under statically unknowns are 2, equation is 1. Then how many compatibility equations are required now? Unknowns are 2, equation is 1. Therefore you need a one compatibility equation. One compatibility equation required now. For this case, how many compatibility? This is what non-zero or 2. Equation is 1. Then you need a one compatibility equation. So to find out the unknowns, we need a 2 equation. Already one equation is there. Now you have tried down one compatibility equation. What is the compatibility equation now? Change in length of the bar is 0. It is a series or parallel or series. So change in length of AB plus change in length of BC should be equal to 0. Change in length of AB plus change in length of BC should be equal to 0. Number of compatibility equations are 1. So which equation I have to take it now? That is change in length of the bar should be 0. Change in length of the bar should be 0. Now change in length of AB plus change in length of BC. Now this is a compatibility equation, total change in length series. How to find out the change in length? PL by AE. AB the one member, BC the one member. Now in both the member, which one is same? Now the prismatic and same material. Axial rigidity is same. Axial rigidity is same. Now what is the load in AB? How many sections are required? No section is required here now. Load in AB equal to RAH. What is the load in BC? Minus RCH. Already one equation, you got it now. We can take out the AE is common. For the load in AB, load at non-junction, what the value in RAH? The tensile or compressive? Tensile. What the length of AB? L by 3. What the load in BC? Load at non-junction. What the load at non-junction? Minus RCH. Equal to 0. So RAH is equal to the one relation. What the other equation now? Equilibrium equation. What the equilibrium equation now? Sigma H is equal to 0. Sigma H is equal to 0. RAH minus P. This relation you got it, compatibility. This is a static equilibrium. Now by substituting in this now, what you are going to get it now by substituting this now. by substituting equation 1 and equation 2. RCH is equal to P by 3. I am getting a positive means assumed direction is correct. Then what the RAH? 2RCH. That is 2P by 3. This also I am correct. Means assumed direction is correct. Once you know the reactions, then directly can vote now. What this RAH you are getting now? 2P by 3. And this is P by 3. So directly what the load in AB? What the load in AB? Axial load in AB. Axial load in AB, how much you have written now? 2P by 3. Tensile. What the axial load in BC? Axial load in AB equal to load at A. That the 2P by 3 tensile. What the axial load in BC? Load at C minus P by 3. That is the compressive. So which one the maximum load now? What the maximum axial load? 2P by 3 tensile. Is a prismatic member. What the maximum stress now? Maximum axial stress. To P by 3A. But if you ask what the maximum shear stress in the bar, what the maximum, this is about the axial stress is on the cross section. But what the maximum shear stress in the bar means half of this now. Maximum shear stress on the cross section is 0. Because of uniaxial state of stress. So to complete this question, what is required now? We need the change in length equation. If you know the change in length equation, then only you can complete the question. If you don't know the change in length, we cannot do it now. It is the simplest one. So once you know the reaction, the problem is same question only. Once you know the reaction, the problem is the same as the previous problems only. This bar is a determinate bar or indeterminate bar? Everybody is going to tell sir indeterminate. It's a determinate bar, statically indeterminate. Statically indeterminate. What is the meaning of statically indeterminate? Reactions cannot be determined with the help of static equilibrium equation. Statically indeterminate means what now? Reactions cannot be determined with the help of the static equilibrium equation. But it is determinate. But how it is determinate now? With the help of which equation? A compatibility equation. With the help of compatibility equation. Same concept is going to be in the beams. At that time we need the deflection equations are required. Propped cantilever beam as well as fixed beam, continuous beam. Propped cantilever, fixed beam and as well as continuous beam. They are all statically indeterminate. So in that case the reactions are going to be calculated with the help of the compatibility equations. There you are going for a slope and deflections. So to complete the reactions of statically indeterminate beams like fixed beam, continuous beam, propped cantilever beam. We need the equation for deflections. Once you know the deflections, then you can calculate the reactions of a fixed beam and continuous beam as well as propped cantilever beam. To complete this reaction, what is required? Now, change in length is required. That already studied now. Mr. Rajput is asking what now? You have to understand, my dear friend. Sir, you are supported by a hand. If you apply a load like this, vertical motion is permitted, sir. You have mentioned vertical motion restricted, sir. I'm going to put it like this now. In that case, support is going to be provided like this. If I'm going to keep it like this, what happens now? Even if you apply load, vertical motion restricted now. There are taken load in the downward direction. Like this, you are going to do it now. So in this case, what a vertical motion is what now? Both the directions is restricted now. Now same question now. A twisting couple is given. These questions are coming torsion chapter now. Tomorrow I'm going to do all these questions on the torsion now. So what change I have to make it now? Angle of twist 0. If I'm going to remove it, what happened here? Angle of twist is permitted. Now I'm going to permit apply a twisting couple. Now angle of twist is restricted, here restricted. Then what should I write down now? Theta of AB portion, theta of BC. Then what should I write now? TL by GJ plus TL by GJ should be equal to 0. TL by GJ. So those you are going to do this question now. Axial loading question. Same question as it is, you can do it now. The shafts in series in a parallel question same as now. Torsion chapter questions now. Same as the axial load questions. Bars in series in the parallel. Only you have to convert that semi-closed ellipse into a semi-closed ellipse should be converted into a double arrowhead. Once you convert that semi-closed ellipse into double arrowhead, all the questions of the shafts in series and parallel can be completed with the same concept now. Somebody is going to miss 2 sections here. 2 sections are not required. No section required. Directly what a load in AB equal to what now? REH plus REH or otherwise plus 2P by 3. Load in BC equal to what now? Minus P by 3. If more than 2 bars are there, then at that time we need a what now? Either ALD or section method is required now, or otherwise free body diagrams now. What is the next question now? Another question. For the prismatic bar as shown in the figure. For the prismatic bar as shown in the figure. Prismatic bar as shown in the figure. Prismatic bar as shown in the figure. Determine. Number 1. Reactions. Number 1. Reactions. Number 2. Maximum axial tensile and compressive loads. Maximum axial tensile and compressive loads. Maximum axial tensile and compressive loads. Number 3. Maximum axial stress. Maximum axial stress. Now below this one, leave the some space. At the end, we'll draw the ALD. So this question can be done by the two methods, first method and second method. Always the first method, the actual method. First method is about just now whatever you have studied. What the first method now? Reactions are determined with the help of the static equilibrium equation and compatibility. That's the first method. Same thing. In the previous case, The bar is considered 2 bar. Now you have to consider how many bars? No, 3 bars. AB, BC, CD. So what the total change in length? Change in length of AB plus change in length of BC plus change in length of CD. Same now. Then you are going to discuss one shortcut method. It is very useful now. So leave the some space here below this now. What should be the first step now? First step is to what now? Is a general method, this is the actual method. What the first step now? Net axial load. Net axial load. What is the net axial load on the bar now? P towards right side. What is the sum of this now? P towards right side. What is the next step now? Introduce reactions in a direction opposite to the direction of net axial load. So since net axial load is going to be towards right side, so generally reactions are opposite to the load. I am assuming what the net load is towards right side. So reactions are going to be towards left side. What is the next step now? So to determine the P1, P2, P3, better to the shortcut method. Your load can be determined by 4 ways. Here better to determine the P1, P2, P3 by the shortcut method I am using now. P1, load in AB. Load in AB equal to load at A. What the load at A? RA. RA is going what? Away from the cross section or towards? Away. Positive. So which direction you have taken? Positive now. Towards right you have taken positive. Then what the P2? P1 plus loaded B. P1 plus loaded B. What the P1 value now? RA. What the loaded B? 2P towards right, left side. Sorry. You made a mistake. Sorry. This is towards left side. Towards left side is a positive. Now this is towards right side is a negative. RA minus 2P. Next, what the P3? P2 plus loaded C. What the P2 got it now? RA minus 2P. What the loaded C? Towards left side. Towards left side you are taking as a positive. So it will be P3 will be RA minus P. So here always what this method the better now. Fourth method the better now. Shortcut method put this now. Next, compatibility equation. compatibility equation. That is what now? Calculation of reactions by using compatibility equation. Compatibility. How many bars are there? No, 3 bars. Delta L1 plus delta L2 plus delta L3 0. Delta L1 plus delta L2 plus delta L3 0. In all the bar, which one is same? No, AE is same. Axial rigidity is same. Then we can take out the AE is common. What is the load in the first member? RA. What is the length of this member? No, L. P2 L2. What is the load in the second member? Now RA minus 2P. What is the length of the second member? Now 2L. Next, RA minus P. This length is once again L. Now you can simplify it. Now you can take it L by A is common. Is the RA. This is 2RA minus 4P RA. So L by A is non-zero. So from this one you are getting RA. RA I am getting 5P by 4. I am getting a positive value. Positive value means assumed direction is correct. Assumed direction is correct. Now to find out the RD. How to find out the RD? Once you know RA, now you can write down P1, P2, P3 now. But in the question it also asks the reaction. Now to find out the RD now, by using sigma H is equal to 0. So I am getting the positive value means assumed direction is correct. My assumed direction is correct. That is what now? 5P by 4. 5P by 4. So now you can use the sigma H is equal to 0. Towards left side I am taking positive. Towards right side is negative. RD I am getting negative. RD I am getting negative means assumed direction of RD is incorrect. So what should I put it now? So assumed direction of RD is incorrect. So it is going to be towards right side. Towards right side. Towards right side. Now what the next step now? First is ask the reaction. Reactions are completed. What the next step you have to do it now? Maximum axial load. What the P1 now? P1 how much here written? RA. RA I am getting positive. Means the tensile load. What the P2? So P2 is minus 3P by 4. That is compressive load. And what the P3? RA minus P. So it is P by 4. Positive means tensile. So what the maximum tensile load now? Five P by 4. Maximum compressive load. Tensile load. 5P by 4 compressive load is 7 minutes. Maximum compressive load is 3P by 4. Now where the stress is maximum now? Everywhere what now? Everywhere what now? Area is same. Therefore maximum stress will be maximum axial stress. This is in which member we are getting now? AB member. Five P by 4A. If you ask the maximum shear stress in the bar, half of this one you have to take it now. If you ask what the maximum shear stress in the bar, five P by 8A. Good. Suyash is good. Good. Once you know the reaction, directly can substitute. Otherwise, what you can do it now? We can draw the ALD also. You can draw it now. ALD the compulsory or optional here optional. Why now? Because already written P1, P2 in terms of RA. So already you know the RA value, substitute it now. But if anybody want to practice it or you want to cross check it now, then draw the ALD. Only your calculations are correct or incorrect. Whether reactions are correct or incorrect, you can cross check it now. I'm starting from right side, I'm starting now. So far you are starting from the left side, I'm starting from the right side. Now this is about of tensile. So this direction should be a positive. This direction should be a positive. Positive means this load is how much now? P by 4. P by 4. And what the next step now? Draw a parallel line until C. Now towards right side you are taken positive, mean towards left side is negative. So P by 4 minus P. Minus 3P by 4. Then draw a parallel line until B. Now this is going to be a positive. Towards right side they are taken as a positive. Then draw a parallel line. Once again this is a negative. Towards right side positive means left side is negative. 0. Now this indicates what now? First of all, what is already 0. Diagram is closed at both the ends, means equilibrium. Then how to what the other cross check now? How many axial loads are there now? 1, 2, 3, 4. 4 vertical lines. What should be the height now? 5P by 4. This height should be what now? 2P. 5p by 4 plus 3p by 4. 8p by 4 means 2p. And what this height now? P. And what this height now? P by 4. So like this you can cross check it now. How P3 is compressive, my dear friend. P3 is the tensile now. How it is the compressive? P3 equal to RA minus P. RA is how much? 5P by 4. 5P by 4 minus P is a P by 4 tensile. Mr. Anurag. Same when twisting couples, if a twisting couples applied, same thing now. When a twisting couple applied, only one extra step, what you have to do it now? Convert them into double arrowed. Convert them into double arrowed. Same procedure will be there now. Only equation will change. In place of P by A, T by ZP. In place of PL by AE, you have to go for TL by GJ. Now I am coming to the shortcut method now. Shortcut method. Once again draw the bar, once again draw the same bar. Draw the same bar once again. Draw this bar once again now. I am explaining this now. This will be useful in objective examination. Once again, in this method, what the first two steps are same. First two steps are same. For both the method, first two steps are same. But what the drawback of this method now? Is a shortcut method. But this method is valid only when axial rigidities are same. Axial rigidity, that is A1, E1 equal to A2, E2 equal to A3, E3. So this method is valid. If the axial ridges are unequal, this method is not valid. That is A1, E1 A1, E1 equal to A2, E2 equal to A3, E3. Now first two steps are same. Then directly can go for the what? The previous method what you had done. First you have written the axial load, then you have used the compatibility equation, then you have calculated the reaction. But here directly can go for the reactions. Calculation of reactions. In the previous case, how you have calculated the reactions? Now, first you have calculated the axial load, then you have used the compatibility equation. All of you can see towards the board now. All of you can see towards the board here. First you have to enter the reactions. You can calculate the RAH. Calculate the RAH. Denominator, you take the length of the bar. Denominator, you take the distance between the supports. Denominator, you take the distance between the supports. What the distance between the supports? Now 4L. Distance between the support is 4L. Then you check it. I am calculating RAH. Next load is applied at what? A B. Load is applied at B. So these both loads are opposite direction or same direction? Opposite. When applied load, this is applied load and reaction opposite direction, then you take it as a positive. When reaction and the applied load opposite direction, then you take it as a, this load should be taken as a positive, plus 2P. And this should be multiplied by the what now? Distance between another support. What this load is applied at B. So what the distance between B and D? 3L. Next, there is one more load is applied. There is one more load is applied. This load P, this P and this RAH. This RAH and this P, both are in the same direction. Same direction means is a negative. And this load is applied at C. What the distance between C and D? What the distance between C and E? C and D, L. I am getting a positive means assumed direction is correct. First drawback is what now? This is not valid when axial rigidities are unequal. When axial rigidities are unequal, this method is not valid now. Next, when you are calculating the reaction, what should be first step now? Denominator, you have to take the distance between the supports. Distance between the supports. What the distance between the supports now? 4L. 4L. Next, where the load is applied at B now? Applied axial load. Applied axial load and reaction. If both are in the opposite direction, plus RAH and 2P. These both are in opposite direction. Opposite direction means plus. And that should be multiplied by the distance between the other support. Where this load is applied B. What the distance B and D? 3L. Next, 2P into 3L. Next, this load. This load and this one what now? This P and RAH. This P and RAH are in the same direction. Same direction means negative. Same direction means negative. And what the distance between C and D? L. 5P by 4. Next, similarly, you can calculate the RDH. RDH. Denominator, distance between the supports, 4L. Now you can see RDH and P. This RDH and P, same direction. Same direction means negative. And what the distance between C and A? Distance should be taken with respect to another support. What the distance between C and A? 3L. Next, this 2P and RDH both are in the opposite direction. Opposite direction means plus. And what the distance between B and A? Distance between B and A is what? L. Now check it now. You are getting minus P by 4. What is the meaning of minus now? Assumed direction is incorrect now. I am getting a negative. Negative means assumed direction is incorrect. So it should be P by 4 towards right side. Towards right side. towards right side. That's all. Applied axial load and reaction. Applied axial load and reaction. Opposite direction, that load should be taken as a positive. And that should be multiplied by the distance between the other support. Applied load and reaction, same direction, negative. Same direction, negative. Denominator should be length of the distance between the supports. Now, if you want to further save the time, shall I calculate both the reaction by the shortcut method, or one is sufficient? You want to further, why you are going for this method? To save the time. So one reaction is calculated with this method. How to find out the other reaction? This is not required. You can use your sigma h is equal to 0. You can use your sigma h is equal to 0. What the other way of finding out the RDH? By using sigma h is equal to 0. What this RAH you are getting a positive 5p by 4. 5p by 4. So initially you kept the RD towards which side now? RD you kept it towards left side. Now you can use your sigma h is equal to 0. Towards left side is, I am taking a positive. Towards left side is a positive. In the equation there is no fixed sign convention. So many times I mentioned, in sigma h, sigma v, sigma m, there is no fixed sign convention. Shall I take the positive or negative? Anyone. Somebody can take a negative. I am taking towards left side as a positive. In static equilibrium equation, there is no fixed sign convention. Student to student sign convention will change. Every student has to follow the sign convention for both axial load, shear force, bendment and twistment. But in static equilibrium equation, there is no fixed sign convention. What is the meaning of this? Now towards left side I am taking positive. Somebody can take the what? A negative also can take it. Since I have taken towards left side positive, towards right side is negative. So my suggestion is what now? Find out one reaction by using the shortcut method. Other one you can find out by using sigma h is equal to 0. So once you know the reaction, the problem is completed. The same as about the previous question now. So this reaction I am getting negative. Negative means assumed direction is incorrect. So change the direction. Next, how to find out the axial loads. Here, which method is better now? To find out the P1, P2, P3, you can find out 4 ways now. But which one is better now? Section method is better. One section is sufficient. So directly what the load in AB, load at A, load the load at A. (5p by 4). Only one section. When one section is sufficient, always better do the section method now. P2. Load in BC. Take a one section. Where you take the section exactly in between. If I take the left side, 5p by 4 minus 2p. Compressive. What the P3? CD member, which is the non-junction? D the non-junction. P by 4. So only one section is sufficient, then better to take this now. But if you are not thorough, then you can go for the ALD or the shortcut method. Only one section is going to be there now. So this is better now. When compared to this now, this will take the less time now. Sir, I want to go for the section ALD, you can draw it just now, you have drawn it previous case now. So remaining is what the same, what the maximum tensile load. Maximum compressive load 3p/4. Maximum axial stress in the bar tensile. Five p by 8a, 5p by 8a. Most of the question they are going to give the axial rigidity same. By chance axial rigidity is not same, then you cannot use this method now. Always I mention shortcut methods are the what now? Best method, but first of all you have to check whether condition is satisfied or not. Wherever require what, cut down the time now. Sir, only half minute difference. That half minute makes a lot of difference in the final exam now, or 1/4 minute. Like that, what 10 questions. If you are able to save the half minute, you can get the 5 minutes time now. That 5 minutes you can attempt the 1 or 2 questions can be attempted now, or otherwise you can cross check your solutions now. If the time is not a criterion, everybody is going to do the questions, but time is what? Time is a criterion in the examinations now. Determine maximum axial stress. Now your shortcut method is valid or not valid now? Some students are going to be not valid, sir. It is a non-prismatic bar. I not mentioned it is not valid for non-prismatic bar. It is not valid when axial rigidity are unequal. Or axial rigidities are same, but the axial rigidity of first bar AE, it is also AE, AE. So you can use the shortcut method is valid. Suppose this is also made of the same material, AE. It's Young's modulus E. Then first method is, sir, shortcut method is not valid. First method is always valid, but for this question, shortcut method is also valid because of some students are what? Sir has mentioned axial rigidities are unequal. Means they will assume non-prismatic bar is not valid now. Non-prismatic bar may or may not be valid, depend upon the axial rigidity. What the axial rigidity of this bar AE. Suppose by chance it is given E, then it is not valid. And some students are going to mention the reactions are 0. The net axial load 0. When a member is fixed at both the ends, net axial load 0 means what now? Reactions are equal and opposite. Reactions are not 0. Net axial load 0 means sum of the reactions are 0. Net axial load 0 means sum of the reactions are 0 means reactions are equal and opposite. By chance what? This I am going to make it free. If I am not provided, no, then at that time this reaction is 0. So whenever I want a bar fixed at both the ends, if some of the reactions are, sorry, net axial load 0. Net axial load 0 means sum of the reactions are 0. Means they are equal and opposite. What the first step now? Here net axial load 0. When net axial load 0 means when fixed at both the ends, when net axial load 0 means sum of the reactions are 0 means reactions are equal and opposite in direction. Then you can assume some arbitrary direction. Now shortcut method you can use it now. This is assumed direction, arbitrary. Previous all the question what you had done it now. If the net axial load is towards right side, you have kept the towards left, but your net axial load is 0. So we don't know the direction of the reaction. You can assume some arbitrary direction. After calculation, I'm getting a positive means a correct. If it is getting a negative means incorrect now. Then you can use the shortcut method now. RA. What the distance between the supports once again now 4L. Now this RA and P same direction means negative. What the distance between B and D? Distance between B and D is what? 3L. And RA and P, this P, opposite direction. These both are in opposite direction. Opposite direction means plus. What the distance between C and D? L. So what this value you are getting now? Minus 3PL upon what? Minus 2PL. So minus P by 2 I am getting now. Means assumed direction is incorrect now. So RA will be Now RD is required or not required, because RA and RD should be equal and opposite. Then automatically RD will be what now? P by 2 towards left side. So now change the direction now. And here it should be now you can find out the axial loads. Once again, which method is better now? Which method is better now? Section method is better now. Directly what the load in AB? Load in AB equal to load at A. What the load at A? Minus P by 2. Then load in BC. Section is required. Minus P by 2 plus P. Plus P by 2. And what the load in CD? Load at D. What the load at D? Minus P by 2. Either you take the left side or you can take the right side. Either left or right side you can take it now. Take a section. I taken on the left side. Either positive, either negative. So what the maximum tensile load now? Maximum tensile and compressive load are equal. Tensile and compressive loads are equal. And what is the maximum stress now? Stress is maximum in this member now. Maximum stress is going to be 2P by A. Somebody P by 2A is written. Somebody is telling P by 2A. 2P by A. In the question is asked maximum axial stress. All the loads are equal. All the loads are equal. The stress is maximum in the where area is minimum. So maximum stress will be in BC member. BC member. Load is P by 2. Area is also A by 2. So stress is P by A. Tensile. Somebody want to use the actual method also, you can use it now. So only what the conclusion now, whenever a bar is fixed at both the ends, whenever a bar is fixed at both the ends, when net axial load is 0. Reactions are equal and opposite when bar fixed at both the ends. When reactions are equal and opposite when net axial load is 0. Now I'm going to do the questions on what a torsion now. Same questions, only the method is going to be what everything is same. Equations are changes now. The same concept about the shafts in series. This is about the concept of the bars in series. So in this question, what now? You want to use the torsion equation, what you have studied now? What are the conditions now? Circular and prismatic, but it's not a prismatic one. Next one is about a pure torsion. It is not a pure torsion. When you are going to get a pure torsion, when you apply the twisting couple at the extreme end, but made of same material, which condition not satisfied now? Prismatic is not satisfied, pure torsion is not satisfied. So these questions are same as about the first you convert to double arrowhead. Now can you find out the reaction twisting couple now? These both are in the clockwise. What the reaction now? What the first step you do it now? Only this extra step is going to be there now. First convert into double arrowheads. Is it a clockwise, anti-clockwise? Clockwise means double arrowhead is going to be towards left side. So already studied all this thing now by using the right hand thumb principle. Already sign convention, everything is studied now. So it is also clockwise. It is also clockwise means towards left side. And this is what the anti-clockwise. Anti-clockwise means towards right side. That's all. So once again here what now? Which method is required now? Either you can use the section method or torque diagram, free body diagram, shortcut method. All the methods are valid, but no method is required now. Why? Only two bars are there. Directly what the torque in AB equal to torque at A. Same what the conclusion you have studied now. Axial load on any member equal to axial load at non-junction. For AB member, which is the non-junction A. So directly what now? Axial load on AB equal to axial load at the non-junction. Same thing what now? The twisting moment or torque in AB equal to torque at A, non-junction. BC, which is the non-junction C. It is also. So what the torque in AB plus 2T, torque in BC plus T. Otherwise you can use the any method, you can use it now. When the methods are required, you have studied now. More than two shafts are, but here only two shafts are there now. More than two shafts. So this is a first shaft. So here all the methods are optional. If you want, you can use it now. Directly you can give it what now? T1 torque in first member, first shaft, that is AB. For AB member, which is the non-junction A, the towards 2T. BC member, which is the non-junction C, T. Otherwise, somebody want to use the section method, you can use it, but section method is optional. If anybody want to draw the torque diagram, now what the torque diagram here now? Same as the ALD. Once you convert into what now? Double arrowhead, the same problem now. Same concept. I am drawing the torque diagram here now. I am starting from the left side. Now towards the cross section are away. Towards means it is positive. So which direction you have taken positive? Yesterday I already mentioned. Whoever is thorough with the ALD, same concept is for the torque diagram. Towards. But when ALD is what away is what a positive, towards the negative. But here towards the positive. So it should be What the next step? Now draw a parallel line until B. Draw a parallel line until B. Towards right side is positive, means towards left side is negative. 2t minus t. Then draw a parallel line. Once again negative. Now to cross check, already the closed at both the ends. And what the cross check now? Number of vertical lines equal to number of twisting couples. How many twisting couples are there? No, three vertical lines. Height of the vertical line equal to magnitude of the twisting couple. What the height of this line? Now 2t. What the height of line? T. So once you convert into double arrowheads, these semi-closed ellipse, if you convert to double arrowed, the problem is the same procedure now. Only difference is what now? When you are calculating the axial load, away is positive, but here towards is positive. And other one is what now? In place of P by A, I have to use the T by ZP. In place of PL by AE, I have to use the TL by GJ. But this is what optional, compulsory, optional. If you want, you can draw it. Otherwise, directly can tell it now. Axial load on any member equal to axial load at the non-junction. Same concept now. This is a compulsory when three shafts are there. Or if anybody wanted the shortcut method also, you can use it. No, same thing now. Then what the next step now? Maximum torsional shear stress. Where the stress is maximum now? This is the maximum torque. Maximum torque. For torsion equation should be applied 2 times. You have to apply the 2 times. But where the stress is maximum, 16t by pi d cube. Torque is maximum in the first member, but diameter is minimum here now. So both you have to calculate it now. Tau 1, 16t1 upon pi d1 cube. That is 32t by pi d cube. Is the maximum torsional first shaft. And what the tau 2? 16t2 upon pi d2 cube. But what the diameter here now? D by 2. (128t upon pi d cube). Is the maximum torsion first shaft. Is the maximum torsional shear stress second shaft. But if you ask the entire stepped shaft, so what the maximum torsional shear stress in the stepped shaft? Larger of this values now. Stepped shaft. Which is the larger value now? Tau 2. Sometimes they are asking what the ratio of these two. What the ratio of the maximum torsional shear stresses now? Tau 2 by tau 1. It's going to be 4. Next, what the next one is asked now? Ratio of angle of twist. Ratio of angle of twist. Theta 1 upon theta 2 upon theta 1. What is the meaning of theta 1, theta 2? For this shaft, which is the free end? C the free end, B the fixed end. First alphabet is free end, second alphabet is the fixed end. Theta 2 means what now? Theta of CB. And theta 1, which is the free end, B the free end, A the fixed end. TL by GJ. In both the case, which is same now? L is same, G is same. Then I have to write down the T2 by T1 and d1 by d2 whole to the power of 4. So what this value now? T2 is how much now? 2t. Is a t. What the d1? d1 is d. So what the answer here getting? 1 by 8. So theta 2 by theta 1. Torsion equation not which should be taken as two shafts in series now. And what the last one is asked now? Angle of twist at C. Angle of twist at C. If angle of twist at B is given. What is given in the question now? Angle of twist at B is given. And what the angle of twist at C? Always what now? Torsion equation valid for what now? Theta is maximum at the free end. For first shaft, which is the free end B. And second one, A the fixed end. Now, what the meaning of theta B? Theta is always possible at the free end. So this is nothing but what? Theta of B with respect to A. First alphabet is the free end, second alphabet is the fixed end. Is a pure torsion. This is the free end, this is the fixed end. Theta B means that is with respect to A. So what is given in the question? Theta 1 is given. This is given as theta. Next, what is the theta C? For the entire shaft, which is the fixed end A. So what is the meaning of theta C? Always you have to calculate with respect to fixed end. For this total shaft, which is the fixed end A. Theta of CA. Whenever is given an angle of twist, whenever angle of sorry, whenever angle of twist is given, means what? That is with respect to fixed end. For the total shaft which is fixed end A. So theta of BA. Next, theta at C means you have to calculate A. But C2A, C2A the single shafts or two shafts are there now. C2A the two shafts are there. How to write down the theta of CA now? Theta of CB. Here to here directly we cannot use the torsion equation. It should be taken as the two shafts. So this should be written as theta CB plus theta BA. I want to get the theta at C here now with respect to fixed end. But here to here how many shafts are there? No, two shafts. So for this shaft, what the free end C is the fixed end. The theta CB plus theta BA. This you have to calculate. That is theta 2 plus theta 1 you have to calculate now. Theta 2 plus theta 1 you have to calculate it. But already theta 1 is how much is given in the question? Theta 1 is already given as theta. But what the, from this ratio, what the theta 2? What the theta 2? From this one, what the theta 2? 8 theta 1. 9 theta 1. But what the theta 1? No, theta. So answer is what? 9 theta. 9 theta. So remember what now? Whenever is mentioned the angle of twist at any cross section, that is with respect to fixed end. For this total shaft, which is the fixed end now, A. So whenever is mentioned theta at B, means with respect to A. Whenever is mentioned, you have to calculate at C, means you have to calculate with respect to fixed end. For this total shaft, this is a fixed end. But here to here what now? Your torsion equation not valid now. Here to here torsion equation not valid. Torsion equation should be applied two times. For BC one time, AB one time. For BC, which is the free end C. So this can be written as what? A theta of CA. C2A is not a prismatic and same material and pure torsion. So you are taking the two shafts. So theta of CB plus theta of BA. Theta of CB means theta 2. Theta BA means theta 1. But already got the what? A theta 2 by theta 1. How much you got? 1 by 8. So theta 2 is equal to 8 theta 1, 9 theta 1. Already in the question theta 1 is given as theta. So answer is going to be 9 theta. Yesterday I already mentioned always first you have to write down the free end and second one is the fixed end. First alphabet is the free end, second alphabet is the fixed end. First alphabet is the free end, second alphabet is the fixed end. So today's lecture is completed. Tomorrow we are going to do some more questions. Now complete these questions now. Chapter number 1. Question number 7. (18), 28 and 39. 7, 18, 28 and 39. Chapter number 6. Chapter number 6. Question number 16. Yesterday, those who have not done the 21 question, you can try it. And 22. 22. 23 and 30. So these questions you can complete it now. So small correction here. So this is 2 you are going to get it. Small correction here now. D1 is what now? D. D2 is D by 2. So this is D by 2. Therefore it will be 32 will be their answer now. Small correction here now. I have taken D2 is what now? D2 I have taken D by D. Sorry, 2D I have taken at the D by 2. So it will be 16. 16 into so this also made correction now. T2 is what? A T. T1 is 2T. So you are going to get it. 16 will be the answer now. Small correction is required. T2 is T. T1 is 2T. So this is 16. Then answer will change now. So this is theta 2 by theta 1 is 16. The 16. Therefore it should be 16 theta 1. So it will be 17 theta 1. So answer will be 17 theta. Small correction, you are not substituted the values properly. T2 is what now? T. T1 is 2T. Therefore this ratio is 1 by 2. And D1 is what? A D. And D2 is D by 2. Therefore this ratio is 16. 16 by, once again what now? Maybe small correction. 8 you are getting. 8 only correct now. 1 minute. 1 by 2. 8 only. So these are the answer. Answer will remain same, but only here I made a mistake. But overall what now? Answer is going to be same you are getting now. So these are the final answers now. 9 theta is the same only, but here only what a small mistake I done it. So today's lecture is completed. So we'll continue tomorrow. So complete this question, will continue tomorrow. So thank you one and all. We'll meet tomorrow. Thank you. For any queries, please try to send it. Otherwise, we'll close the session now. Those who are thorough with the today's lecture, the remaining questions, shafts in series, fixed at both the ends also you can do it, but I have not given that question. Tomorrow I am going to do a question. But those who are thorough, they can do all the questions. Once you convert the semi-closed ellipse into double arrowhead. So welcome my dear friends. So there are no queries. I am going to close the session. We'll meet tomorrow morning. Thank you.